Okay, let's discuss today with a sorting algorithm. And under sorting algorithm, there is one strategy called as divide and conquer strategy, or divide and conquer algorithms. So, when we are talking with respect to divide and conquer, uh, we have two different algorithms under that. That is merge sort and quick sort. So, what is meant by sorting? You have been given one array which is having some random numbers into that array. So the sorting algorithm will sort those numbers in either ascending or descending order. So by standard convention, let's assume that we have to sort the array in ascending order. So now we have there is first method that you start with the first element and then starts finding its position, and otherwise just compare first two and then take the smaller one in the front to the left side, and a larger one to the right hand side, and this way we can proceed. So these are some of the techniques under sorting which falls under selection sort or bubble sort, and their complexity is of the form big O of n square. Then there are some fastest algorithm which falls under divide and conquer algorithm strategy. So whatever I said, like quick sort, bubble sort, insertion sort, these are some of the sorting techniques which are there, and their complexity is big O of n square, because each array we are going to traverse the array twice, because we'll take one element and one element is traversed over the entire array, so that is one traverser of the array for one element. So similarly for n elements, each element you will have n traversers, so that is why n into n, which is equal to n square, and which is a big O of n square complexity for the basic sorting algorithms which I have told you. So now under divide and conquer strategy, this strategy, like whatever divide and conquer algorithms are there, they perform better over our this selection sort, bubble sort or insertion sort algorithm. So under divide and conquer we have two different types, like one is merge sort technique and another is quick sort algorithm. So what exactly divide and conquer will do? So you have an array of size, let's say this is the array, I could just say this is an array and it has a size, let's say it has a size of n. So this size n array will be again divided into two arrays of size n by 2 each, and the same process we proceed further. That is what our divide and conquer strategy or merge sort algorithm says. So in the sense, divide and conquer algorithm will help us, or under divide and conquer algorithm we can just divide the given array into two smaller parts and then we just go on solving this. Okay, so let's discuss what is merge sort. So as I was telling, we have an array of size n. So this array has some n elements. Now this is a initial step, and then in next step what we are going to do is we are going to divide this n size array into two different arrays of size n by 2. So this is one array of size n by 2, this is another array of size n by 2. What if n is odd? So in case if n is odd, then one array is of size n by 2 plus 1, like n minus 1 by 2 plus 1, and another is n minus 1 upon 2. Okay, yeah, so you can say that this is n by 2 size array and this is another n by 2 size array. So now this n by 2 size array will again subdivided into two arrays of the sizes n by 4 and n by 4. So now this is again divided into size n by 4, n by 4. Similarly, this is also divided into two arrays of size n by 4 and n by 4. So now we have divided into two arrays of sizes n by 4, n by 4. So now what will happen, we will follow this division procedure till we reach to the end, that we will stay with the array of size 2. So when we started, it was array of size n, then this array of size n is divided into array of size n by 2, and that process we go on doing till we remain with array of sizes 2. So those many divisions we are going to do. So we are divided a size n array into some numbers of some number of arrays of size 2, and now this size 2 array we have to sort and again re-merge them. So now let's say we have some arrays of sizes 2, 2, 2, 2, something like this. Now how you will sort array of size 2? So array of size 2 will be sorted into in just one go, that if this is greater, then just take it in the left hand side or put it in the right hand side. So just one comparison you have to do and you will sort it, and then after sorting we are merging this size 2 array into size 4 array. Similarly, now these two will be merged into size 4 array, and this process will continue, that we will get some, again here you have, let's say, k arrays of size 2, then we will be getting now k by 2 arrays of size 4, then we will be getting k by 4 arrays of size 8. So just we will go on merging them till the end, and now after that just merge these arrays and we will be getting size 16, and this process will continue till we reach a array of size n, and each and every time, like let's say this is an array of size 2, so every time while merging we are just comparing them and we are sorting them, we are just arranging them as per our requirement, and then this is becoming a array of size n, which is a sorted array. So this is what our sorted array, and this technique is widely used in most of the algorithms. So this is a sorted array, and larger data sets this technique is more efficient compared to the quick sort. So quick sort we have not yet discussed, so in subsequent video we will discuss. So this is a merge sort. So let's try it with an example. So let's take an example. So now we have array, let's say we have an array with the elements 8, 9, 6, 5, 3, 12, 4, 10 and 7. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have an array of size 9. So now what we have to do, as per the merge sort, we have to divide this array into two equal parts. But we have array of size n. So array of size 9, which is now our n is equal to 9. So we can divide it into two arrays of size 5 and size 4, because it is 9 is not an even number. So first element we will take here, first section, another section we will just divide there. So now 8, 9, 6, 5, 3. This is an array of size 5 will be coming here. Then which is 12, 4, 10 and 7. So this is one array of size 5. The next is another array of size 4. So now size 5 array we can divide into one array of size 3, which is 8, 9 and 6. Then this is another array of size 5 and 3. Okay, this is one array of size 4 and 12. This is another array of size 2, which is 10 and 7. Now you can see this size 3 array we can again subdivide into 8 and 9, 6, or you can just make it 8, 9 and 6 in any way, fine. Okay, and now this is 5 and 3, so size 2 array. So at this stage we have all the arrays with sizes 2. So now you can look here, 8 and 9 are already sorted then 6 is there. Now while comparing this, we have to take this 6 is smaller than 8 and 9, so it will be 6, 8, 9. When we are merging these arrays, it is 6, 8, 9. Now when we are merging this array and this array, because we have merged these two, then okay, so I'll just keep it here 5, 3 again. I'll keep 4, 12 here, and then I'll keep 10 and 7 here. So now I have to merge 5 and 3 with 6, 8, 9. So this is like this. So now when you are going to merge them, first 5 and 3 will be sorted, which will be 3, 5. 4 and 12 will be sorted, which is 4, 12. This is 7, 10 after sorting these two. Now 3, 5, you just start merging them. You should just go through the traverse over the array. So 3 is the smallest, 3 will come first, the next smallest is 5, then it will be 6, then 8 and 9. Now you come here, while merging them you can see that 4 is there, next smallest is 7, then 10 and 12. And you can see that if array of sizes n by 2 are there, even I will be traversing over two arrays, but both have the indices. Like if I equal to 0, I will be just checking its 0th element and its 0th element. So whichever is the smallest element will be taken first, then next element will be taken first. Okay. So this is how it will be merged. And now you can look here. Now I will be merging these two arrays, which will be again 3, 4, 5, 6, 7, 8, 9, then 10 and 12. So this is our sorted array with merge sort technique. So instead of traversing array twice, we have just go on dividing this one single array into two arrays of sizes n by 2, and we just went on dividing it till we reached the array of size 2 or 1, and then we just went on remerging those array by sorting them in ascending order. Okay, so now how to find the complexity of this algorithm? So see, we had an array of size n. Okay, so this array of size n was divided into two arrays of size n by 2 at each stage. Now this array of size n by 2 was divided into two arrays of size n by 4 at each stage. Similar way, this is also divided into two arrays of n by 4 at each stage, and similar way this will be again n by 8, n by 8, n by 8. I'll just write it down. N by 8, n by 8. Okay, so now you can just see this process will continue till we reach array of sizes 1 or 2, and this process will go on. So if I have to find its complexity, how I could find? So our first aim is find its recurrence relation. And I think in my previous videos I have told you how you can create a recurrence relation. So now I have a problem of size n, which I am dividing two problems of size n by 2 at each iteration. Now I have a problem of size n by 2, that problem is divided again into two sub problems of size n by 2. So I will be writing recurrence relation as T of n equal to A into T of n upon B plus this is some f of n, I will say. And what is f of n? A local computation time, to divide the given problem of size n to a number of sub problems of size n by b. So now what is our b here? How many problems? N size problem I am dividing into n by 2. So b is 2 here, and how many sub problems I am dividing? 2. So my T of n will become 2 times T of n by 2. So I am dividing a problem of size n to problem of size n by 2, and how many sub problems I am making? 2. So I am dividing 2 sub problems of size n by 2 at each stage. Now what is the local computation time, that is f of n, to divide a array of size n? So let's say I have, let me change, okay, so I have an array of size n. So I have an array of size n, and now this array of size n I have to divide into 2 arrays of size n by 2. So anyway, I have an array of size n which I will be dividing into 2 arrays of size n by 2. So to do that, I have to check each and every index of that array, because I know the value of n. Let's say value of n is 9 now, or value of n is 9. So, or value of n is, let's say 10, not a problem. So I know the n, so I have to take first 5 elements of that array, which is your n by 2 array, into another array or another sub array, and remaining 5 or 4 elements into another sub array. So actually speaking, I am traversing over each and every element while dividing that into 2 sub problems. So that is why what is f of n here? F of n is the amount local computation time required to do the sorting. So at this stage, I will be traveling array of size n, and to divide that array of size n to 2 n by 2 problem, I will be traversing over all elements of that n. Now I have array of size n by 2 and n by 2, then again I have to traverse each and every element of n by 2 and each and every element of this n by 2. So it is again, if you take the sum, each stage you are taking n as a local computation time to divide this. So this will be the recurrence relation now for us, that is t of n equal to 2 times t of n by 2 plus n. This is a recurrence relation for merge, sort. And if you solve this, because I have already explained how we can solve the recurrence relation, if you solve this, we will be getting the complexity as big O of n log n. So we have a complexity of merge sort algorithm as big O of n log n.